Everyone, thank you for joining us today. Welcome to our joint GoodWe Waxman webinar. My name is Raj Sidhu. I'll be doing a very short presentation for those who didn't attend yesterday on a little bit about GoodWe and the start of the energy storage product portfolio. There is a lot to take in, but first of all, I'll introduce you to Sarah from Waxman's, just to give you a brief about Waxman's and our partners Waxman, and how we work together to supply to the market. Lastly, Colin will provide an in-depth overview of our energy storage products and the benefits of using them. Okay, thank you, Sarah. Just going to hand over to you.
Thank you very much, Raj. Good morning, everybody. I'll give you a brief presentation on Waxman Energy and Waxman Battery Storage. For those of you who don't know who I am or weren't in the webinar yesterday, my name's Sarah. I'm the Sales Director for Waxman Energy and Waxman Battery Storage. So I've got a little bit of a presentation for you. So Waxman Energy and Waxman Battery Storage, we are specialist distributors of residential and commercial energy storage solutions. This is our facility, just some of it. So we're part of the Waxman Group with over 50 years in distribution. The Waxman Group consists of 9 companies with 3 key divisions: fibres, ceramic tiles and renewable energy. It all began with the distribution of Japanese fibres, which soon became a leading European distributor of a range of flame retardant fibres, primarily used in protective workwear and upholstery. They diversified into other markets and expanded the business to include the distribution of ceramic tiles, becoming one of the leading suppliers of ceramics and mosaics within the UK. We had further expansion into the renewable energy in 2007, and now one of the UK's largest distributors of renewable energy and associated products. It's a family-run business, and the company is led by Chairman Richard Waxman, and we've built our business on our commitment to developing strong and lasting relationships with our partners, and we're able to source world-leading products across each company within each division. So the energy division. So both Waxman Energy and Waxman Battery Storage are located at the same site in Elland in West Yorkshire. This is our energy building, so we do practice what we preach. We have got solar on there, as you can see. We've also got car chargers around the corner and battery storage solutions within the unit. So we're an independent solar distribution company, and we choose only to work with the most trusted and respected brands. So as our customers, you can be confident we're receiving only products of the highest quality. What sets us apart from our competitors is our technical know-how and our can-do attitude. Our main focus and our drive is customer service. So we do everything right from the design element, your wind and snow load calculations, PV sol designs, right up to the delivery and the technical support thereafter. We do have a technical team. So the whole team are always on hand to answer any questions and make sure they give you the best advice. So what we can offer. So we are experts in renewable energy solutions, and both companies do work together to offer a complete package for the installers. So we sell everything from the modules, battery storage, inverters, mounting systems, EV chargers, and the cables and accessories. So we basically take you right back to the meters. An award-winning team. Last year was a really good year for us. We worked really hard and we won 3 awards. So we won Company of the Month with Sustainability Today in June. We won Company of the Year for 2019 with Sustainability Today, and we also won Best Renewable Energy Products Distributor for Yorkshire in the SME News for 2019. So this is some of the team that you will deal with. 5-star service. Service is really important to us. So we do believe in treating customers like friends, and we're always there and available over the phone, email, or even offer face-to-face support over a brew and a biscuit. Most recently, due to the COVID-19 situation, we have taken to online webinars and online meetings if you prefer. So, we are adaptable and we will do whatever suits best for you and your business. Obviously, after sales support, we've touched on that, but from design right through to delivery, you can trust us to be there every step of the way, including ongoing after sales support as long as you need it. Our facilities. So the warehouse space, we've got 400 square foot just for the energy company alone. This enables us to hold extensive stocks on site, so large commercial systems, it's really not an issue. If you've got a job, you need 1,000 panels, it's not going to affect our stock holding, and we can deliver next day. We've got some really good hauliers that we work quite closely with. What's a little bit bespoke to us is our training centre. So it was the first training centre in the UK to open, based around energy. So it's an on-site training facility. It was purpose-built and it's opened its doors in 2018. We've probably had a lot more, over 300 installers since this was written, so we're probably up to about 400, 450 that have been through the doors. You know, anybody who's wanting to wishing to further the knowledge on the renewable energy products, we run quite regular training sessions when it's going to be open. We've got live rigs, as you can see. We've got battery storage solutions, EV chargers, roof models for the mounting systems, as well as a classroom and lecture theatre. We have just recently bought some webcams for in the training facility. So what we'll be doing in future is hosting both internally and externally. So if you do live quite a distance away from our facility, you can log in and sit the same training session that we'll be hosting indoors via Zoom. So I hope you've learned a little bit more about us and what we actually do. So if you've got any questions, feel free to drop me an email or give me a call. The numbers are on there. I'll hand you back to Raj. Thank you very much. There you go, Raj.
You need to unmute yourself, Raj.
Thank you, guys. For those of you who were with us yesterday, and thank you for attending yesterday, I'm briefly just going to go over a little history about GoodWe and go straight into the energy storage product portfolio. It is quite extensive, and it's just a reminder of what I went over yesterday to understand how the models are on the DC side and on the AC side for single phase and three-phase energy storage solutions. So if you just bear with me, for those of you who were with us yesterday. One key point, I'm not going to mention too much about the COVID-19 crisis, the epidemic crisis, but we can all see that economies here and around the world are going to be stressed because of this. But I've been reading up quite extensively on this and had a few conversations with industry colleagues about this, and the road to recovery will be led by the green industry. So the future is looking promising as we take the next few steps to the road to recovery. Right, we get going. The agenda for today is a brief introduction from myself, energy storage product portfolio intro, and then Colin will go into a more in-depth look at some of our products on the energy storage side. Right, GoodWe company has been established a decade now, and in that short period of time, we've reached some major milestones. But before we entered into any international markets, we set up the first of our R&D centres. We are technology-driven, technology-focused, and there's a lot of innovation that comes out of our R&D that we basically put into our products. In 2014 to 2015, we set up GoodWe UK, a service centre in Holland. A team was put in Australia, and it was our start of our partnership with BYD and TUV Rhineland. As you can see there, in 2014, we actually launched our first hybrid, DC-based hybrid, the ES, which we're still selling successfully now. 2016 to 2017, we increased our relationship with TUV Rhineland and received some quality awards in that period. We were selling our products in IKEA stores in the UK and in Europe through our partner Solar Century. The second R&D centre was set up. A service team in India was set up. And more importantly, we launched our SEMS monitoring platform. SEM stands for Smart Energy Management System. It's basically our own platform that is evolving all the time, basically to handle things in the future like EV charging, wind, small mini power plants, etc. It's evolving all the time. But it's a free monitoring platform. It's been designed by GoodWe, and it's not. We don't use a third-party company to host our monitoring platform. 2018 to now, we've now got a team in Europe, based in Munich. We cover Spain, Italy, Portugal, Czech Republic. There's a new team in Poland now as well. We have a service centre and personnel in Mexico and Brazil. So within that period, that last decade, our global reach has increased. Just to give you an idea of some of our offices around the world, and obviously we have one in the UK with Colin and I, and we also have a call centre to back us up. But these are the personnel. We've now just employed a guy in the USA, and we're going to have a team in Canada in the future. Some little known facts about GoodWe. We have the 2 R&D centres, over 1,100 employees, estimated over 1,100 employees, but most of them are R&D technicians. So as I said, I mean, the focus is on innovation and technology. We are technology driven. We also have 130 patents, which, you know, we've developed and invented, and we implement that technology into our products. Some awards, EUPD and All Quality Matters Awards, we've won 4 years consecutively. The Red Dot Award was awarded to one of our products for not just the aesthetic looks, but also for the technology within the products. And in 2019, we received the independent IHS market report for top 6 global inverter shipments globally. Some of our partners, as you can see, they're Waxmans, but you know, we deal directly with companies like Bosch, Sterling Wilson, Tata Power, and as you can see, there's some big names. This was awarded. We actually won the deal on this. We've been working on it for over a year. GE, as you know, are a blue chip corporation. They looked at over 100 inverter manufacturers globally and decided on using GoodWe as a partner. What this means is, in some markets, our inverters will be sold under the GE brand on regular string inverters and energy storage products, but not so much here in the UK currently. Just after receiving the GE award, we've had an official report from Wood Mackenzie that GoodWe have been awarded the #1 storage inverter supplier globally. So our products, our energy storage products, we shipped out in the last 12 to 18 months more inverters than any other manufacturer, and that's our market share on the energy storage sector is increasing. Right, let's get into the products. Right, as you can see there, we're featuring hybrids to the left-hand side and AC coupled storage systems here on the right-hand side. Hybrids, DC, as you know, are all on the DC side. ES, EM are the ones that we sell here in the UK, EM predominantly. EH and EHR, EHR means hybrid ready, so it's a solution that we can sell you if required. Basically, these are all single phase inverters for residential use. The difference is the EM works with the low voltage batteries, as you've seen from Pylon and BYD. The EH series works with the new high voltage batteries that come in more and more on the market. Now, just to give you an idea, the EM that we sell in the UK is available in a 3, 3.6 and 5 kilowatts. You have G98, G99 certificates as well as G100 for export limitation. And as I said there, it works with the low voltage battery. High voltage battery technology is coming more and more into the marketplace now, so our products are ready to work, which are compatible with high voltage batteries. These are all small, lightweight, compact. The ET, this is another DC based hybrid that we're actually selling now in the UK. Difference is it's 3 phase. It comes in 5, 8 and 10 kilowatt versions. Again, works with the high voltage batteries. There's a few key features to this I'll go into briefly, and then Colin, I think on his slide, has some more detail. Right, SBP, BH and BT. How to distinguish these is anything with an E on them is basically a DC hybrid. Anything with a B in it means an AC coupled storage solution. So it's a retrofit solution, can be a retrofit solution. So SBP, BH, BT, anything with a B in means AC coupled. SBP we actually sell now in the UK, works with a low voltage battery, comes in 3.6 and 5 kilowatt versions. The BH will be coming in, works with a high voltage battery from 1 to 6 kilowatt. So you have, you know, quite an extensive range to fit for any solutions that you may have cut up and coming for energy storage. Now the BT is a 3-phase AC coupled solution. 5, 8 and 10 kilowatt models are available. We've just brought these into the UK. Again, they work with a high voltage battery. So as you can see from this slide, we have a solution on the DC hybrid side for single phase and 3-phase, and also on the AC coupled storage solutions, single phase, 3-phase, but also products that will work and are compatible with low voltage smart batteries and high voltage smart batteries. The ES, as I mentioned in one of the first slides, we actually brought into the market in 2014, and we're still successfully selling this. The reason why this slide's not one of the newer products is a lot of the features are the same throughout the range. So you have automatic switchover. If the grid fails, within 10 milliseconds, it switches to backup. You can charge the batteries from the grid if required, but in the UK on the DC side, we don't actually do that. But in other markets where people know that the grid will fail the following day and they've had a bad PV day, there's not enough charge in their batteries, they can charge their batteries from the grid, and they can charge their batteries from the grid and have it ready for when the grid fails the following day. All our products come with a smart meter. Smart meters, well, the way the smart meter works is, Colin's smiling at me through the window. So the way the smart meter works is it picks up the excess flow of energy which is not being used by the load within the property, and directs the excess energy to the battery, and our product charges and discharges accordingly as and when the load needs it. So these all come standard throughout our battery energy storage product portfolio. The reason for energy storage, as everyone knows, is to basically use everything you generate as much as you can. A heat sink. We have a big heat sink on the back. There's no actual fan in this product, so there's no moving parts, and it does dissipate the heat evenly. For connection to SEM's monitoring portal, you've got Wi-Fi, LAN and Bluetooth options currently, and 4G will be coming in soon. The ET series, this is the 3-phase hybrid. We're actually selling this now in the UK. There is a project somewhere up in the north of England where I think they're rural railway stations, and they're installing these on rural railway stations with the high voltage pylon tech batteries. But again, automatic switch over to backup if the grid fails. You can charge your battery from the grid. These come all included, smart meter and CTs. You can limit your export to 0, so you try and use up everything you can. You have 100% overloading within 60 seconds, and it can help with unbalanced power supply, 3.3 kilowatts per phase. One of the extra functions from the ET is if, for instance, you have, say, 100 kilowatts on the roof or 60 kilowatts on the roof, but in this example it says for 100 kilowatts, you can have 10 ET units connected in parallel, all with a separate bank of batteries. Now, each of these banks, depending on what battery manufacturer you're using, whether it's Pylon or BYD, for instance, can be up from 11 kilowatt hours storage up to 22 kilowatt hour storage for each battery bank. So that's quite a lot of storage there. They're all controlled by this ancillary product which we sell. It's called the SEC 1000 Hybrid. Now, this basically makes sure that all of these inverters that are in parallel work in unison, so they can charge and discharge at the same time. Some of our battery partners that are compatible with our products are, you probably have seen these on the low voltage side, the BYD, the Alpha, which Waxman sell, the Pylon Tech, which is quite common in the UK as well. So these are the low voltage battery manufacturers that we work with. And then on the high voltage side, as I said, more and more of these are coming into the marketplace. You've got the BYD B-Box high voltage, the Pylon Tech Power Cube, LG Chem, and the Dynas Tower. There are more battery manufacturers coming on, but what I can tell you is GoodWe will very soon be bringing their own low voltage and high voltage batteries into the marketplace, because there is a big demand for batteries globally currently. Also, we're hoping before the end of the year, we're going to have these commercial storage solutions, BTC and ETC they're called. As I said before, anything with an E on it, ETC is a hybrid, DC-based hybrid storage system. Anything with a B is an AC coupled storage solution. These are going to be available from 50, 100, 150 up to 250 kilowatts, both on the DC and on the AC side. You have adjustable reactive power feature, built-in remote shutdown, automatic switchover, can help with unbalanced loads. It is a modular design. These cabinets are roughly about 2 meters tall, and currently they're compatible with BYD, the new BYD commercial batteries. So these are commercial energy storage solutions, which can be AC coupled retrofit or a hybrid solution for medium to large scale commercial buildings. Right, I talked briefly about SEMS, but SEMS is now available in quite a lot of languages, as you can see there. We have servers out of China, in Europe, Australia, and North America. These, we also have backup servers that kick in automatically if one server fails. Obviously, we have a service in China as well, so we've got quite a lot of coverage for our monitoring. Just a little screenshot of one of the screens you can get on SEMS. There's a lot of information to be gained, and you can download and understand how your plants, well, plant or multiple plants are working. To the left here, you can see system type, capacity, when it was commissioned, where it is. Bottom left, you can see your generation calculations, daily, monthly, annual. To the right hand side, status report, operational status, and you can gauge this information here. There's actually a little graph here, which is your PV curve. You can scroll along it and it gives you information. If you stop it there, it will just, information will pop up and you can actually see what's going on at a certain point in time. Down the bottom, your inverter status, inverter information, you can see actually how it's working. Around here, you can't actually see it on the screen, you see main dashboard. So a lot of our clients on the larger installations have this in their reception areas. There's environmental statistics with, you know, CO2, how many trees you're saving. You can see multiple plants. Colin will show you a snapshot of this, of how you can actually basically tailor this to how you want it. But there's a lot of information to be gained from here, and you can design it to how you want to display it. Up here, you don't have to have the GoodWe name. You can actually put your own company name in there as well. Right, I'm just briefly going to go through these before I hand over to Colin. Some ground mounts here, 11 megawatts in Holland. Just to give you an idea, you know, it's not just energy storage, but we do string inverters from residential to utility scale. It's 5 megawatts there in Holland again, 200 kilowatts and 350 kilowatts in the UK, Suffolk and Lancashire. It's a 2.3 megawatt just gone up north of London, in Hertfordshire with our commercial inverters. some residential jobs in South Africa and China. One there for the UK, right in the middle there with EM units from battery storage. And there's quite a lot more, but we can't feature all of them. Just want to point you to this screen. It's from our marketing department. Basically, if you're on LinkedIn or Facebook and you share our posts and you get a lot of thumbs up, every month our marketing department hold a competition, and there's a £50 Amazon gift card they send out to the winners. Right, I'm just going to hand back over to Colin.
Thank you. Thank you, Raj. Good morning, everybody. Welcome to day 2 of our webinar. For those of you that didn't make it yesterday, I'm responsible for the pre-sales and service activities for GoodWe in the UK. So today I'd like to talk to you mainly about our residential solutions for battery storage. And I'm just going to bring that up onto the screen now. Hopefully you can all see that now. So as I say, I'm mainly going to be focusing on our residential solutions that we can offer you, and then just briefly talk about our commercial solutions that will be coming in later, and hopefully at the end, towards the end of this year. So you've heard Raj just introduce you to our product portfolio. So I'd just like to pick up upon some of the terminology that's been used for those of you that aren't perhaps so familiar with energy storage systems. So you will have heard Raj mention the words like DC coupled, AC coupled, retrofit, hybrid inverters, charge controllers. So I'd just like to explain a little bit about the meanings of these. So when we talk about a DC coupled system, such as this in the block diagram at the top of the screen here, we are talking about the direct relationship of DC output from solar panels into the device, which is going to be charging and discharging the battery. So you can see here there is a direct relationship. When we talk about an AC coupled device, you can see here that there is no direct relationship between the solar panels and this device here. You can see that there's no DC input from the solar panels, and that's the battery there, which will receive the control information from this, what I'm going to call the charge controller. Now, when I say a charge controller, if you think of our hybrid inverter as a combined inverter and a controller, a charge controller in one box, that's what we refer to as our hybrid inverter. And if it's a charge controller, there's no PV input. So it's important to understand the difference between the AC coupled and DC coupled, because both of these devices are capable of charging the batteries from the grid. Now, that's important for you to know in order to make the right decision about which is the right product for your end client. So if we look at the charge controller here at the bottom, the AC coupled solution, they will already have an inverter, and they're now looking at perhaps the ability to add battery storage. So by adding in our charge controller here, we're going to achieve the ability to store power in the battery. However, the idea of this system is that any power that is entering the battery, when perhaps they're going to charge the batteries from the grid, well, when that battery releases the energy, it's only going to release the energy to support the load, and it cannot release that energy back through the feed-in tariff meter that they probably have. And if they had their original inverter system back in 2011, say, they're going to be on quite a high tariff, like 50 pence per kilowatt hour. And that's still running now for the next 15 years or so, for the length or the duration of the remainder of the feed-in tariff, which is running. So as you can imagine, if that energy was released out of the battery when it has been charged from the grid, and particularly if they are on a tariff where they're buying cheap energy at night, they're buying it for, say, I don't know, let's say 8 pence per kilowatt hour, and they're releasing it, and they could potentially release that energy through their feed-in tariff meter, they're going to now be paid at 50 pence per kilowatt hour. Now, you can't do that. That's actually fraud. So that's why we do have this AC coupled solution, because you're not going to pass any energy back through the feed-in tariff meter. It cannot happen. So that's why we refer to this as retrofit, because this is the kind of solution that you're not going to impact upon your customer's feed-in tariff. If we now look at the DC coupled solution, let's imagine that the same customer now who's got this feed-in tariff, and they're looking at battery storage, but potentially all their original inverters also failed. So if you were thinking that you could now replace that system with an all-in-one hybrid inverter, you have to be very careful, because that feed-in tariff meter is going to be connected on the AC output side of the on-grid connection. Now, if they were to charge that battery from the grid and release that energy back out of the battery, that is going to pass back through the feed-in tariff meter. So you have to be careful. So it's not really a suitable solution. So the AC coupled solution is the better option. Now, in today's market, when we've got new customers and we don't have a feed-in tariff, yes, we do have the new SEG export tariff. Again, you have to be careful here, but of course, if you're buying energy from the grid to charge the batteries, and it was to go through this feed-in tariff meter for the export tariff claim, then of course you'll be buying power at a higher rate, but you wouldn't be receiving much back from the feed-in tariff suppliers. So you probably wouldn't want to do that anyway, because it's not very cost effective. But if in that situation you did install this, there are new meters available, the type of meter that can, or a net meter, I believe it's called, and it can take that into account. So hopefully this has just outlined some of the differences, what you need to take into consideration for buying or supplying your customers with the correct type of equipment. Okay. So the other terminology you've heard being used is low voltage and high voltage batteries. Well, when we talk about low voltage batteries, we're talking around a nominal voltage of 48 volts. When we talk about high voltage batteries, it's actually a range of power. And you can see here I have an example, or let's consider the example of using our ET product. Now that has a voltage range of between 180 volts and 600 volts. It just depends how many batteries you're using as storage. Now, we do have a battery compatibility list that is published on our website, and that will give you all the information you need to know about the which batteries are suitable for connecting to which system, which product, GoodWe product. As I said earlier, retrofit, that's another term that's used, and you usually associate that with our AC coupled storage solution, or indeed I like to refer it to being a charge controller. So hopefully that's just a bit of clarification there on the terminology that's used. Okay, a common theme running throughout all of our products is the ability to configure all of the systems using an app. It's called PV Master, and this tool is used, as I say, for configuring the system, but we also have other apps such as the SEMS app, which is the version of monitoring remotely what the system is doing. So the common theme, it's all app controlled. As I said, all of our systems are lithium battery compatible, and as I said, the compatibility list is published on our website. All of our systems have an on-grid side and a backup side output, so in the event of a grid failure, then within 10 milliseconds we do have this backup port available to supply any essential circuits. Also common to all of these devices is the fact that we can perform export limitation. That may also be referred to in our documentation as any anti-reverse current. And this is achieved through our smart meter, which comes as part of the package when you buy it. Okay, so what I'd like to explain to you now is a bit about the operational logic of our equipment. And I'm going to do that by virtue of looking at, first of all, our hybrid inverter as an example. Now, we have here the input, DC input connection from our solar panels into the hybrid inverter. And out of the bottom here, you can see we're connected to a lithium battery. That's both the power and that yellow dotted line there. Hopefully you can see that. That indicates the BMS connection between the hybrid inverter and the lithium battery. Now, here on the output side, we have our on-grid connection. So this is the way you would connect a standard inverter. You'd supply energy in to support the loads of the building. So this is our on-grid connection. But in red, you can see here, we do have a dedicated AC output for any essential circuits. Now, there is a separation between these two circuits, and in no way will the backup side be connected to the on-grid side. Now, if we continue to look at this then, what we have here is an RS485 connection to our device called the smart meter. So this is a device which is going to be used to intelligently control the need for charging the batteries or discharging the batteries. And you can see here that this smart meter is connected to a CT, and this CT has to be placed between the incoming point of the building and the supply from the grid. So the way this works then, let's consider we have some loads running here, and the amount of power that's being generated by the inverter from the solar panels is actually greater than what is needed by the loads of the building. Now, I should also mention that there is no priority between the backup loads and the on-grid loads. So the power will supply equally to either side, the backup side or the on-grid side. So we've got this excess power. Now, if we start to export that excess power very, very quickly, this CT is going to recognize the fact that there's power going out to the grid, and it's going to signal back to this smart meter, which is going to direct the hybrid inverter to not allow that power to go out to the grid. It's going to start charging the battery. Now, that battery will continuously charge as long as there's excess power. But once the battery has reached 100% state of charge, then the only thing that can happen is that the power is going to start to be exported out onto the grid. And that's the essential charging logic that we have here. Okay, let's now have a look at what happens on the reverse side of things when it comes to discharging the batteries. So let's imagine here we've got this same inverter. We've got a PV supply coming in. It's daylight, and we've got PV power being generated by the inverter. But perhaps the loads within the building at this point in time is just not quite high enough to be met by the output of the inverter. So the CT is going to detect a potential need to draw power from the grid, but it's going to determine the fact that if there's any power in the battery, and if there's any charge capability in here, then to support the load, where it's going to start discharging that battery to assist in running all these loads. Now, again, if the amount of power in the battery or that's being generated by the hybrid inverter by extracting power from the battery, if it's not quite high enough, then of course we have to draw power from the grid in order to be able to support these loads. Now, at night time, of course, we don't have any PV being generated, so the only way we can support these loads is if there's energy left in the battery will discharge for as long as it can to support the loads, and then the grid will be able to support the remaining or the difference in power requirements. And of course, once this battery has fully discharged, then the only thing that can happen at night is that you're going to be supporting drawing power from the grid. Excuse me. So let's now have a look at the scenario where we've actually lost the grid. So here you can see, or hopefully you can see anyway, the fact that there is no on-grid connection. So the on-grid side of this hybrid inverter is not active. So the only thing we've got here that's active is the inverter, which can take power from, as long as it's during daytime, it can take power from the solar panels and also from the battery. So again, if the loads are demanding more power than what can be received from the PV side, then there'll be a battery discharge to actually support those loads. And at night time, the only thing that can happen here, again, if there is enough power left in the battery, then you're going to discharge that battery for as long as you possibly can to support these essential circuits. Now, when it does drop over or drop out from the grid, it's a switchover time of 10 milliseconds, so it's very, very fast, and it's quite seamless. So we tend to think of it as a UPS level switch time. Okay. All right, so that's a bit about the operational logic of our hybrid inverter. So we ought to take a look here at our AC coupled or our retrofit solution. So what you can see here is a scenario where perhaps this is a customer that got their original inverter installed within the property, and now we've added in on the left hand side here all the equipment which is necessary to perform the battery storage. So here you can see our charge controller. Excuse me. So in exactly the same way that our hybrid inverter would work in terms of charging and discharging, so will the charge controller work in the same way. But of course, you don't have any PV input, direct PV input into the charge controller. What you do have though with our charge controller, or the difference is that with the smart meter that's provided, not only do we have the CT clamp to detect the power flow between the building and the grid, we also have this second CT here, which is supplied, which is going to monitor the output from the inverter that's installed within this building. This inverter can be any inverter, it doesn't have to be a GoodWe inverter. But the idea of using this CT is to collect data up onto our SEMS portal to give you an overall picture of what's actually happening with the whole system. So this is quite a good piece of equipment to have here to get that data. Now, let's have a look at another solution. Now, you heard Raj talk about the ET three-phase battery storage solution, which is a hybrid inverter, and the fact that you can actually parallel up to 10 of these devices on the on-grid side. You can actually parallel. So I've just got a smaller diagram here, hopefully to make this a little bit clearer, of three 3 inverters or 3 ETs which are connected in parallel, and you can see by the yellow dotted line here on the AC on-grid side, these devices are all parallel together. Each device or each ET will be connected to its own set of lithium batteries, and of course each ET does have its own individual backup circuit or its essential circuit support. So what happens here then, when there's charging and discharging capability, when the system is on grid, the SEC 1000 hybrid, which is connected by RS485 to each of these inverters, this is going to intelligently control the charging and discharging of the power across the whole combined effort of the batteries. However, when or in the event of a loss of power to the building, we have a grid loss, then of course we're going to drop the AC connection. Now when that occurs, each individual ET is going to be capable of supporting its own individual backup load via the particular battery which it is connected to. So here on the left, as Roger's already mentioned, and I'll talk a little bit about this later on, is the ability to support unbalanced loads. Okay, so let's move on to the next slide here. Just having trouble with the buttons. Okay, let's get that onto the next slide. So we're going to look at another solution here. We refer to it as a capacity extension solution. Now what that means is, within a property, you can add a hybrid inverter to an existing standard on-grid inverter, and the way this will work is, because we have a smart meter here, it's going to be monitoring the power flow back to the grid or from the grid. So it's going to be monitoring the AC excess power that is being generated by both the hybrid inverter and the on-grid inverter. So when it does detect that there is an excess being developed, the batteries will charge from both the output of the hybrid inverter and the on-grid inverter. So what happens in this circumstance, it's a bit like an AC retrofit system, the way this is going to behave, because it's going to detect the AC power here. Okay, let's move on to the next slide. Here we have a solution for a particular type of customer that perhaps may not be quite ready for purchasing a full battery storage solution. And we call this our EHR. Now we do sell this in three ways you can actually purchase this equipment. You can buy it as a fully loaded hybrid inverter. So option A here, it has the battery function and it comes with the smart meter, and those two elements will enable this to perform as a hybrid inverter. Option B here, you won't buy the battery function, but you do want to purchase a smart meter, and the purpose of buying it with a smart meter is to perform any export limitation if required. Or the third option here is you don't buy the battery function option or the smart meter. So it's just like a regular inverter, and that gives you the option at a later point to actually upgrade and buy both the smart meter and this battery function. When I talk about the battery function, I'm talking about the battery activation code that you purchase from GoodWe to actually enable all the hybrid side of this system. And then it performs exactly as a hybrid solution. Right, here we have our all-in-one solution. This is what we refer to as an ESA. Now you can see here it's nicely packaged in a tower. Now at the top of this tower you can see that we have a 5 kilowatt hybrid inverter, which is IP65 rated. Here, just beneath the inverter, we have our pre-wired box. It's IP65 protected, and the purpose of this box is to house and neatly house all of the cabling aspects and monitoring aspects of the wiring requirements. So on the left hand side here, you can see that within this box we have the Wi-Fi module. This set of breakers here is for providing a disconnect to the battery supply. This red switch here in the middle, this is the isolator for the DC isolator from the PV. And on the right here, we have the breakers for both the on-grid side connection and the first one is the backup side breakers, and on the right hand side here is the on-grid breakers. In the center here, we do have a bypass switch, and the point of that is that if there's any maintenance required on this inverter and you have to power this inverter down, then when you lose the power to the inverter, the circuits which are connected to the backup side, the power is going to be lost. So if you flicked this bypass switch before you perform any maintenance on the inverter, then you're going to get a grid supply to the backups, to the circuits on the backup side. So you're not going to lose power to those circuits. And finally, at the bottom of this cabinet, in the bottom half, we do, this is where all the batteries are stored and located in here. And you can see here on the right hand side that there is smart fan cooling within the cabinet to help the cooling aspect required. Okay, so that's a little look at the all-in-one solution. Here I'd like to just introduce you to some of the features of controlling the battery side of our equipment. Now, as I said earlier, we do have apps to control and configure the system, and the example here I'm going to show you is the app called PV Master. Now, within PV Master, on one of the pages, one of the configuration screens gives you the options here. At the top left is the option called General Mode. Now, this is the mode where it defaults to, and probably the most widely used method of charging and discharging the batteries. It's going to allow the batteries to self-manage itself within the property. Now, at the bottom here, and I'll come to this in a bit, there's another mode called Backup Mode, which you can see highlighted red. But what I'd like to do is just draw your attention to a setting within the advanced settings part of the app. So when we're looking at general mode, you may want to consider how the batteries behave in an intelligent way. So you may be considering, well, what happens during a power outage, or in fact, do we suffer really from any power outages? And in which case, if it's a frequent event that occurs, then you may want to consider reserving some power for the situation when you do lose the grid. If you don't set up this capability and just leave it as default, then when you are operating in general mode, the battery will be allowed to charge and discharge as it sees fit during the course of the day. Now, if you got to the end of the day and all the battery had been depleted down to its set level of depth of discharge, and you happen to have a power outage, then you've got no reserve power left in the battery. So that may be something you need to consider. Indeed, in places like South Africa, that is a very high consideration, and in which case we have this mode, backup mode. Now, this mode only allows the battery to discharge in the event of a power outage. Now, this obviously is quite frequent in South Africa, so they tend to reserve that power for when they lose the grid and if their blackout times. So here we have another way of controlling the batteries and what they do. And again, coming back to this app, you can see here we have an option, and we call it economical mode. Now, economical mode does allow you to set up a number of timers within the app to allow the battery to charge from the grid at certain points during the day. So you can see here, during the setup, you can set the start time of when the batteries start to charge. You can set the end time. You can set the amount of power by which the batteries are being charged with. You can select whether the batteries are charging or discharging. And then you can set up repeat cycles. So if you are in a situation where you'd like to take advantage of charging from the grid, and you're on one of the type of tariffs that has a low nighttime rate, then you can set up a repeat loop if you so desired to regularly charge the batteries from the grid. I'd just like to draw your attention to a little bit more information about what you can see on the SEMS portal. Now, I'm not so sure this is going to be too clear in this presentation to you, but at the top left hand side of the screen here, we have a daily and historical view of all the aspects of the inverter. Now, we're only showing one data trace here just to hopefully simplify what you can see, and this is showing some information about the power, about the load of the building throughout the course of a day. Now, what you can't probably see here is the fact that we've switched off all the other information that can be seen on this screen, just for hopefully makes it a little bit more viewable. But we could switch on the view, and this is the standard way that you will view things, that all of these functions will be enabled. So you can see the PV generation. You'll be able to see how the battery is performing, whether the battery is charging or whether the battery is discharging. You can see the energy flow to the meter, and you'll also be able to view the state of charge of the batteries, which is quite an important one to be able to view. So that's the daily and historical view. Just beneath that, then we have excuse me, we have our, well, we call it real-time monitoring. It's as real-time as it can possibly be, because the inverter is presenting this data up onto the portal, so there is a slight lag in the information when it's actually arriving at the portal. However, it gives you a nice graphical view of the power flow and the directional in which that power is flowing, and you can see above each directional arrow it's indicating the amount of power in a particular direction. On the top right hand side of the screen here, we have daily, monthly, yearly calculation. Now, this is to provide you information about the self-use ratio of the PV, how much energy you're self-consuming, how much you're consuming from the battery. So it's giving you that detailed analysis there. Below, we have the self-use analysis. So these two pie charts here are giving you an indication of self-use from the PV and also the self-consumption of the battery, so we can see how much energy we're buying or self-using from the PV. So this is just a brief snapshot of some of the views that you can see within the portal. Okay, it's referred to as a one-stop solution. So this is the equipment which you're going to receive when you open up the box. So you get the inverter in there, and you get all these accessory devices within the box. So, but what I'd like to draw your attention to is the fact that we do have these pre-assembled cables, and you can see here one is called a smart meter cable. This is the communications cable which you need to connect into the smart meter. I'll come back to that in a second. We have another communications cable which is connected to the battery. Now, this length of cable is around 3 meters. It doesn't need to be that long, because you're usually going to be locating the batteries right next to the inverter. The smart meter comms cable here is longer, around 10 meters. Excuse me, around 10 meters. And that has to be connected, as I say, to the smart meter. And the smart meter is usually located at the incoming point to the building, because the CT clamp to which this smart meter is connected needs to be monitoring the incoming at the incoming point. Now that CT clamp cable length is around 1.5 meters. Now this cable length cannot be extended. So that's why this device needs to sit at the income of the building. Now, the distance between where this is located and where you locate this inverter will depend upon whether you need to extend the smart meter cable. Now, you can do that. You can extend it up to 100 meters, but it's only this cable that you can extend. We also have the Wi-Fi module within the box, but you can also see here that soon we're going to have a Bluetooth module that you can use. This is a little bit more stable than Wi-Fi, so that eliminates any unstable Wi-Fi problems, but that's just used to be able to configure the system. We also have a set of communication splitters, so when you need to parallel the ET device, then you will need to use these communication splitter cables, and that comes in the box. Okay, so that's what we call our one-stop solution. So I'd just like to return back to the a bit of information about the UPS level switch time. And this is all this is showing is that we are compliant with G98, G99 to still maintain the fact that we are going to achieve that. So when the inverter is on grid, you can see here by virtue of relay 1 and relay 2 being closed, we do get power from the grid available to the on-grid supply of the inverter and the backup supply of the inverter. But relay 3 is closed, so there is no direct connection between the backup side and the on-grid side from the inverter output power. When there is a grid outage, and this obviously can happen, then what happens within 10 milliseconds, relay 1 and relay 2 open and relay 3 closes. So there is now no direct connection between the backup output port of the inverter and the on-grid supply of the inverter, so no power can get back into the grid. So we maintain the anti-islanding requirement. And as I said, we do refer to this as a UPS level switchover time, and it's quite seamless. Right, this is just an indicative to show you that in a controlled laboratory environment, this is just going to give you an idea of the times or the relative times to install the aspects of this system, and maximum of about 45 minutes under this very controlled environment. Of course, this is nowhere near what you could perhaps expect in a real situation, because you're going to come across all different kinds of issues to come around. But as I say, this is just an indication of the relative times to install each aspect. Okay, another important thing I'd just like to address is that you're going to need to, when we want to get the information about the system onto the GoodWe portal, we have to connect by Wi-Fi and pair it to a local router. We do have options for a LAN connection as well, but let's just consider the default method of connecting by Wi-Fi. So you're going to pair these two devices together in order to be able to transmit the information. Now, we do have a number of methods of being able to do this, but one of those methods I'm just showing here on this slide this 4-step sequence is to use the app to set up the pairing between the inverter and the router. Okay, once we, well, let's have a look at some of the basic commissioning requirements here. We can commission the inverter using our PV Master app in a number of ways. Firstly, by talking directly between the app and connecting to the Wi-Fi signal that the inverter broadcasts. You can make that connection. If you've already made that connection, you can make the app talk directly to the router. And then finally, if you've already connected this system onto the portal via the SEMS app, there is also a way of configuring the system as well. However, whatever method you choose, then we do have a sequence of steps that you need to go through in order to be able to set up the system correctly. And the first thing you'd need to do is set the country code. So obviously here in the UK, we have G98, G99, so you choose the appropriate country code. You then step on to the next part of the sequence, which is setting the operation mode. So as I said earlier, by default, you'll enter this mode here at the top left, general mode. Then you press next, which takes you on to the screen for configuration of the batteries. Now the appropriate battery here will either need to be selected, or lately there is some self-detection of batteries, self-detection of batteries as well. But however, after that battery selection has been made, you then step onto the next screen by pressing next, when you will arrive at this section called meter test. Now, providing that you have configured everything correctly, installed everything correctly, then when you perform this meter test, this is going to indicate to you whether you have connected the CT clamp onto the incomer correctly. If you haven't, it's going to tell you. However, this does require that everything is correct. Finally, and it's not shown here on this screen, that in order to configure the system, you have to apply the settings you've just chosen across this sequence of steps. Now you just press a confirm page will come up, and you press yes, and those settings will be applied. So that's how to configure, and it's very, very quick. Okay, so I said I'd return to talk about the bidirectional unbalanced output capability. Now I've just got a couple of little diagrams here to help explain this. At the top here, for both the ET and the BT, we have the inverter here, and we're also going to consider the situation where we're not allowed to export anything back to the grid. So on phase 1 here, we have a load of 1 kilowatt. On phase 2, we have a load of 3 kilowatts. And on phase 3, we have a load of 2 kilowatts. Now, because we are able to configure the inverter to support unbalanced loads, that means if, say, this inverter was generating its maximum of 3.3 kilowatts on each phase, however, as I said, we're not allowed to export anything to the grid, then because we have unbalanced load capability, each phase output of the inverter is able to supply the needs of the loads on each phase. So as I said, phase 1 needs a load support of 1 kilowatt. So phase 1 of the inverter will produce 1 kilowatt. Phase 2 is 3 kilowatts, and that's what phase 2 of the inverter will produce, and so on. Load 3, 2 kilowatt requirement, and that's what the inverter is going to produce. If we didn't have the unbalanced load capability, and it was producing a maximum amount of output power, and we have to observe again the fact that we can't export anything to the grid, so we're applying export limitation, then this output of this inverter on each phase phase would reduce down to 1 kilowatt on each phase. So we'd supply 1 kilowatt to each of the loads here. We'd fully support load 1, which is 1 kilowatt. However, as we're only supplying 1 kilowatt to the loads on phase 2 and phase 3, and what that means is, in order to run these loads, we're now having to purchase power from the grid in order to be able to support these loads. So as you can see, it's not very effective. So that's why we've introduced the unbalanced load capability. At the bottom of the screen here, you can see an inverter generating 4 kilowatts on each load, on each phase. But we have here different load requirements on the phases. We have on phase 1, 1 kilowatt, phase 2, in this example, 2.5 kilowatts, and on phase 3, 2 kilowatts. So you can see here, because we have the unbalanced charge capability, we are now picking up the individual excess power production on each of the phases, and that combined total output power can now be used to actually charge the battery. So I think that's a very useful feature to have. Now up here you can see it says 100% unbalanced load, so that means that on one phase we could be supplying absolutely no power at all, but on another phase, or the other 2 phases, we could actually be supplying the maximum amount on each of those phases. So it's 100% unbalanced. It's achievable on both the backup and the on-grid side, but on the backup side it's default. The configuration of unbalanced load choice is in the app, and there's no extra devices to achieve this. It's already, all the equipment comes out of the box, and the app will be the only tool that you actually need to configure this system to behave in this fashion. And just a little note here, of course you need to have this all configured and set up correctly for this to actually work properly. Okay, now you saw Raj show this in his presentation. This is just a reminder here of the batteries, the low voltage batteries that we have in our range that we support, and the high voltage batteries as well that we support. And of course the batteries will be supplied along with the equipment from Waxman. This is a screen. Well, what this screen shows you here is the fact that our equipment is going to be highly integratable, because we do support the Modbus RTU protocol, and we'll be supporting the TCP Modbus protocol as well, and also we're SunSpec protocol comparable. We use the SunSpec protocol as well. But what this is just showing you is it's highly integratable with other devices within perhaps a situation like a virtual power plant. So it's going to be very configurable. So finally then, oops, let's jump screen. I'll just go back to here. Now I know Raj spoke to you about this earlier, but as he said, that's coming into play will be our AC coupled and our hybrid storage commercial size solutions between 50 and 200 kilowatts. It's got an adjustable reactive power, so we can counteract any effects of the type of building which has any reactive types of equipment in there. So between minus 0.8 and 0.8 adjustable. We have the remote shutdown capability. So from an operation and maintenance point of view, if the system does need to be shut down, then this can be achieved remotely. It's a very modular design, as you can see, the way it's all presented here in these equipment racks, and UPS level switch time capability is also included within here, so we get the backup supply within that 10 millisecond operational range. And as I just mentioned in couple of previous slides, it does support 100% unbalanced output load. So this brings me, I think I've gone through that a little bit quicker than I anticipated. However, this is an overview of our storage solutions. I hope you found that of some use. I'd just like to, just as a reminder, if you'd like to, oh, that's disappeared. If you'd just like to give us a thumbs up on any of the platforms, and then you're in with the chance of also winning this $50 Amazon voucher. So thank you very much. I'm going to hand you now back to Raj, and there we are. I've stopped sharing. Over to Raj.
Thank you, everyone. Thank you for attending today's webinar. We hope you found it useful. One of the points that Sarah mentioned earlier about more training, more remote training, and they're going to be using webcams on their test rigs. This is something that we're going to be actively pursuing with our partners at Waxman to give you more in-depth hands-on training over a video link. So you can sort of see how these things are configured, how these products are configured, and how easy they are to install, and also to figure out what to do and what not to do, basically, when you're commissioning our products. So thank you again for attending. One last thing, we would appreciate any comments back to Waxman's if you require more training on, say, commercial, industrial, or residential inverters. Monitoring solutions. I mean, we have a whole host of presentations that we can provide. We just need to get some more feedback from yourselves through to Waxman's, and we'll go ahead and arrange some more trainings. Colin, there is a couple of questions there on Q&A that you might just want to quickly answer for Suki. But apart from that, thank you for everyone attending. I'll hand over to Sarah.
Thank you, Raj, and thank you everybody for attending the training session. Yeah, I'd like to reiterate what Raj has said. I'm going to be sending out just a little form for completion, just for some feedback on what you found interesting, what you find you need to further your knowledge on, and also on there is going to be a couple of questions regarding current inverter or battery storage solution usage. What brands you are using, why do you use those brands? So we, not everybody knows everything about every product that's on the market. So what we're trying to look at is what pushes you to use a certain brand. Is it because a product has a certain feature? You might not be aware that GoodWe has that feature as well. We do have stock on both domestic and commercial and battery storage solutions in our facility. So, there's options there, and looking at alternative brands and switching over to GoodWe. Yeah, I think Suki has asked a question, so I'll mute my microphone now so Colin can answer. But again, thank you very much for attending.
Suki, I'll give you a call. I'm having a bit of difficulty with this Zoom at the moment, so I'll come back to you.
Okay. Thank you again, everyone, and we'll see you next time. Cheers.